Hey, I'm Mario Champion, the Liquibase Pro product manager, here with James Bennett, the sales engineer, to introduce an excellent enhancement to Liquibase Pro's policy checks, which is a governance and compliance solution. The enhancement we'll talk about today is Python-based custom policy checks. Just as a quick background, Liquibase Pro is the paid and fully supported version of the venerable Liquibase OSS project, which has been around for near 2 decades and serves millions of users. The Pro version is built to support and enable modern automated database DevOps practices like governance and policy enforcement, auditability and observability, and the like. Specifically with policy checks, your teams are able to both shift left and automate the policy, security, governance, and compliance work, which is too often still done manually as a pre-deployment blocker by devs and DBAs and DevOps folks. That is, policy checks automate that process. So no more waiting on manual script reviews or trying to ensure by hand all the DB schema changes follow security and permissions policies, the scripts follow coding standards, and so on. So the new Python-based custom policy checks enable you to meet your specific and nuanced guidelines and policies. If the official out-of-the-box checks do not fit all your circumstances, and to be honest, we can't ship checks for everybody's specific circumstance. So imagine all the solutions that can be created by the Python devs in your organization and shared across your organization. If you can code it in Python 3.10 plus, have JDK 17 plus, and Liquibase 429 plus, simply link your Python script in a custom policy check to solve your specific needs. So the overall benefits: ensure compliance is specific to your tech stack. You develop at your cadence. You can share across your entire organization. So enough of that. It's pretty easy to understand. What's going to be next? James is going to show us how easy it is to link your specific Python script to a custom policy check and generally wow us with a useful demo.
All right. Thanks, Mario. Okay, so if you're familiar with the policy checks, you know that one of the commands that we can use is the checks command, which actually shows you all of the configured policy checks. Right now, I just have one existing check that's configured here, which is the table name must be updated. And I've already built this in Python. You can see that we've got some Python code here that is actually pulling in some modules that Liquibase is actually going to provide. And then for this particular check, we're going to loop through all of the changes, the pending changes, and then determine whether or not the table names are in all uppercase. Now, I'd like to create a new policy check today. And that's going to be one that is a database check that is going to look to ensure that all of the primary key names have the pattern PK underscore followed by the table name. So I've already created this in Python, as you can see here, and we're looping through all the objects in the database. We're going to determine if it's a table, and if it is a table, does it have a primary key? And if it does have a primary key, does it meet with our naming conventions? And this particular policy check would not be available into our normal policy checks. You would not be able to do it just with the regular policy checks that we currently have. So I've already coded this, and I'd like to go ahead and configure it. So once again, if you're used to the policy checks, you know that this is going to be very familiar. One of the things you can do is customize an existing rule. And so what I'm actually going to do now is build this policy check inside of Liquibase. So the first thing it's going to ask me is to give it a short name, and I'm going to call it PK naming convention. Then it's going to ask me for a return code. I'm just going to pick number 1 here. And finally, a short description of what this particular policy check is going to be doing. So I'll go ahead and add that. Now I'll set the script scope. This can be either changelog or database. In this particular example, this is actually a database scope. And then here is the message that is going to be displayed to the user if this particular check is violated. One of the things you may notice is that I'm using some placeholders here. You can see I've got underscore, underscore, current, underscore, name, and then underscore, underscore, name standard. This is going to be important later because I'm actually going to have my Python script fill these in with informative information for the user. Next, it's going to ask me about my script type. This is just going to be Python. And then it's going to ask me for where does my script actually live. So I've created a scripts folder here in my repository, so I'll point it there. Next, it's going to ask me for any script arguments. I don't have any in this particular example, but say we were trying to define a policy check where we wanted to keep our varchar fields to be 255 characters or less. I could specify that maximum here, And then if I ever needed to change it, I could just change the check definition without modifying the Python code. So these variables will actually be passed in to my Python code. I don't have any, so I'm just going to hit enter. And I don't require a snapshot for this particular case, so I'm just going to take the default. So now my check has been defined. If I rerun my checks show here, you'll be able to see here that now I have two custom policy checks defined, the one I just added and the original one that I have here. Now I'm ready to go ahead and test these. So I'm actually going to check these back into my source code repository. So I'm going to just put add new check. Not a very descriptive message here, but that is the one I'm going to choose. And so I'll commit and push that back up to my repository. Now, once back inside of GitHub Actions, I'm actually going to execute my workflow. All of this looks good. I'll take the defaults and I'll go ahead and run my workflow just to test my new policy checks. If I've done everything correctly, then we actually should see a couple of failures here because I purposely set up inside of my Oracle database some checks or some objects that should actually fail these particular checks. So we're running through the checks right now. You can see here that we've actually displayed the checks that we have configured as part of my Liquibase workflow. And now it's actually running the policy checks that I've previously defined. Okay, so now that that is finished running, you'll see that we've actually do have a couple of violations. And if you're not familiar with our operational reports, these operational reports are created by Liquibase Pro to provide your users with an easier way to consume information from Liquibase. You can quickly see that we've got two minor errors that are detected. And if I scroll down a little bit, we can actually see the details. In the first one, you can see table names must be uppercase. And you can see here that the message is identifying the specific table inside of my change set is employees. You may recall that we actually used placeholders in this definition as well. You can see I replaced __ table name with the name that is actually of the object that is actually violating this check. And if I scroll down a little bit here, I can actually see that my naming convention was also violated. I've got a primary key called PK1, and it must actually be defined as PK addresses. And so both of these scenarios are ones that I set up. This check looks great, so I'm now actually ready to promote this check to be used by other teams within my organizations. Back to you, Mario.
All right, thanks, James. That was an excellent demo, and I like how you went all the way back to the repo with your policy checks. That's a very standard workflow, and it's good to know that we can do that. So just as a quick recap, Liquibase Pro policy checks allow you to define and adhere to your code standards and ensure compliance, and it really shifts left so developers can write safe code every time. And the custom policy checks really enhance that ability so that you're not waiting on Liquibase and out-of-the-box checks to create solutions to your specific nuanced policies. You can have your guidelines and your organizational standards, and if you can codify it in Python, you can make it into a Liquibase policy check. Like we said, download Liquibase 429 Plus and the Liquibase checks extension and get started today. Thanks, y'all.